Okay. We were doing fun. How many people were not here last day? Anybody else? Okay. Extremely quickly, we're looking at reactions in which the number of electrons changes. They used to involve oxidation, so they're called oxidation reduction. You go from a big chungus of ore down to a small amount of metal. So that's why that one's a reduction, but that one actually turns out to be iron plus 3 going to iron. So that is actually, instead of a reduction, that is a gain of electrons. There's mnemonics for that. Oil rig and Leo the lion goes grr. Reduction is gain of electrons. Oxidation is loss. When we look at this, the carbon's going from CO to CO2, plus 2 to plus 4, so it is losing electrons. Oxidation is lost. The terminology gets weird. Well, not weird, but if this one's undergoing reduction, then and this one's undergoing oxidation, then this one is helping that one be reduced, which means that is the reducing agent. So the reducing agents are oxidized, and the oxidizing agents are themselves being reduced. Let me give you a little assignment in that to help keep it clear. Those are the mnemonics. I like Leo the lion goes grr, loss of electrons oxidation, gain of electrons reduction. And it turns out because they're losing and gaining electrons, we need to know what these charges are. Those charges.
No, it's S.
Why is there so much talking?
It was before.
They're up here. Grab them. POS. These charges then are really important for figuring out whether or not it is changing.
Could you grab me one?
Maybe it's the back door. Andrew, can you grab the back door? Huh? Grab the back door. I'm distracted by the sound.
Is PLOR just one page?
Yeah, we did that last day, and then S is what we're doing now. So in order to determine what's being oxidized and what's being reduced, we need to know what their charge is, except we don't call it a charge. We call it an oxidation number because we even apply this when they don't have a charge. So just as I said, that carbon is plus 2 if it was to have a charge, and that carbon is plus 4 if it was to have a charge. Those are called oxidation numbers. If that has a charge, the oxidation number and the charge is the same thing. Hydrogen has 3 possible charges, normally plus 1 with a non-metal. Occasionally, if you find it with a metal, it'll be weird and be minus 1, because hydrogen has twice the chance of a date on a Saturday night and go either way. But it prefers being plus 1. It would rather give up an electron with a non-metal. So you've seen that in acids. And then if it's by itself, just like anything in its natural state, which was the first one we did, it's 0. And then we were about to do oxygen. Were you not here last weekend? No. Okay. 2 of them.
I already have an R, but I don't
Oh, okay. Okay. O2 or O3, this is oxygen's natural state. What would it be? Natural state, what would it be? Minus 2? If this is minus 2, then the whole thing should be minus 4 because there's 2 of them, so it's probably not. Should be 0. Anything in its natural state from the very, very beginning, if it's in its natural state, you know, Cl2, H2, M, S8, O2, whatever, if it's in its natural state, its charge is 0. Now, normally it is minus 2. These are all the exceptions. What would it be with fluorine in this particular case?
4.
4?
Maybe.
Why 4?
Because oxygen is -2 and fluoride is -1.
No. Oxygen isn't this is an exception.
Oh, then I don't know.
So, knowing what fluorine is, what would oxygen be?
I thought 4 because it has the 2 there, but I don't know.
What's each fluorine?
2?
Minus 1. And we have 2 of them. So what would oxygen be?
3.
-2.
Minus 2?
No, +1.
Plus 1?
Right.
Two.
-1.
2. I'm going to go through all the numbers.
Zero.
Minus 3, put up your hands. Minus 2, minus 1. 0, plus 1, plus 2, plus 3. Okay, I'm going to stop. What's the charge on fluorine?
-1.
-1. And a little hint is we always write the negative ones second and the positive ones first. How many fluorines do we have?
2.
So this side is -2. If this side is -2 and the whole thing's 0, what must this oxygen be? So oxygen here is +2.
Wait, can you do that again?
Wait, can you explain that again? Sorry.
What's the charge on fluorine?
-1.
-1. How many of them do we have? 2. So this whole charge on this side, it must be -2. If the entire thing is 0, then what must be the charge on oxygen in order to make it 0?
How do you know it's 0?
There's no charge written there.
Oh, so it is 0.
The whole thing is 0. Oxygen isn't.
We just put -1 for 0.
So if the whole thing's 0, fluorine with 2 of them ends up being -2. What must be the charge on this particular oxygen? +2. So oxygen in this case is +2. It is normally -1. These are the 3 exceptions. If there are 2 hydrogens and hydrogen is written in the front, so H2O2, what is the charge on that oxygen? Working it out in a similar manner.
-2.
There's 2 of them though.
So -1. Can we turn on the light?
Oh, sure. Nobody turned it on, so I thought maybe it was a low light day.
The screen is so bright.
The screen is so bright
Actually
though.
blinding me.
I mean, if I did, let's see.
No,
Oh.
no.
Oh.
No, not that
Not
one.
that one's
Not that
Oh.
one.
Oh.
Here, turn off.
Well, I can do this,
Turn off the back, maybe.
Yeah.
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 and then I think it has like a say when.
Turn off the front.
Oh yeah.
Yeah,
There, right
just-
there.
Right there.
And then
There.
there.
Is that good?
Yeah.
Excellent. Little dim lighting. We go like this. We're trying to figure out what oxygen. What is hydrogen
+1.
in this case?
+2.
+2 for the whole thing because each hydrogen is +1. So we got +2 on this side. What must this side then be?
+2. Or minus.
-2. And if we have 2 oxygens, what must each oxygen be? -1. So oxygen in hydrogen peroxide is -1. Oxygen, fluorine is so electronegative it can turn oxygen into a positive molecule for an oxidation number. And when it's by itself, it's 0. Those are the 3 exceptions to the rule that oxygen is -2. It's almost always -2. But those particular cases, it is not.
Wait. So
Yeah, how is it -1? Is it 0?
yeah, I'm a little bit confused.
No, bro.
+2
because
-2 equals
hydrogen
0.
is +1.
And then you
for
want a
each
-1.
hydrogen it has, there's 1 other oxygen. So
I'm listening to
it's
Sam.
oxygen
Sam's
plus
doing a great job.
Oh.
Yeah, oh, that was great. What was your question? Say it again.
Like if you like do whatever, both the charges is +2 and -2.
Yeah.
And if you add those together, it equals 0.
Right, so the whole thing is 0. But what is oxygen in that?
-2. 0.
In here, it's -1. You have hydrogen.
Wait, how is
You have hydrogen that's +1, right?
yeah.
And you know the whole thing must equal 0, right? So what is each oxygen?
-1.
Right. That's what that means. We're just getting the oxidation number on oxygen. What are the group 1A metals? Yeah, what's that family called? What's their family name? Alkali metals. So all the alkali are +1. What are the group 2A?
Alkaline
alkaline earth. And what are the 7,2B? Sometimes known as, I think, 17. Seven B. We also know them. They're always minus one. What group is that?
This one. It's this one. But I can't
Which
remember.
row is that?
It's like the.
I want to say something gases.
Is it noble gases or halogens?
Halogen.
One of those, yeah.
Halogen.
Which halogens? Listen to that. Thank you. There are many exceptions to these. If there's an exception, it's good because they're going to be with something like oxygen or something. You're going to have to work them out. But most of the time, you can look at them and go, "Oh, they're regular ones." For all of these, are they their exception or are they doing the regular thing? You'll look at the compound, and then you'll go with the vibe. The vibe will tell you.
On the
Dude, on the table, that's those are just numbers.
Those are just what?
It's VIIA.
Yeah.
VIIA.
Yeah.
VIIA is here. Manganese.
My table must be backwards. It says that's B.
Oh, I can take a look after. Because I didn't know different tables labeled that differently. The sum of the oxidation numbers equals the charge of the particle. So, for example, let's see way of SO4 minus 2. That means, what do we know? What is oxygen normally?
-2.
Minus 2 times 4. What's minus 2 times 4? Negative 8. So S, sulfur, minus 8 must equal minus 2. So what must sulfur be?
Plus 6.
Plus 6. Because only 6 minus 8 would give you minus 2. So we use this as the overall charge. Similarly, what would nitrogen be if it is O3 and minus 1? Using the same method I used over there.
Two. Or. Yeah.
-1.
What is that for?
4. Yeah.
We have nitrogen plus, what's the charge in oxygen? No, no. What is, it's right above. What is oxygen almost always?
-2.
-2. And we have 3 of them. -6. So plus minus 6 must equal the overall charge of minus 1. What must nitrogen be to have this overall equal minus 1? 5. So you can the overall charge of a molecule is the sum of all the oxidation numbers in the molecule.
When do we know if oxygen is -2 or not?
You go with the vibe, or these are the only cases in which it isn't. And the last oxidation number rule is the oxidation number is the same as the charge. So what is the oxidation number for chromium?
-3.
Did you just say -3?
No, I said 3.
Excellent. And what is the oxidation number of sodium? 1. What is the oxidation number of sodium solid? 0. So if it has a charge, and you can obviously see the charge, that is the oxidation number as well. Use those rules. Figure out the oxidation number. Well, actually, We're after the one I'm pointing to. All the other ones should be ones that you just get through the rules quite quickly. But let's write them all down to practice and get those. Neha, Ella, question? Etienne is not here. Andrew's here. Ashley's here. Ella's here. Bill is here. Josh is not here. Okay, Haley is here. Max is here. Nathan is here.
Yeah.
Very good. Neha's here. Nick Myers not here. Sam is here. Sonny's not here. Taz is not here. And Theo's not here. Okay. First thing I'm going to ask the two that you should know, and then I'm going to ask someone the one that we have to figure out. So, what is sodium? Katie. If I asked you in this compound, what's the charge on sodium?
+1.
+1. And Lavina, what's the charge on oxygen? Was always the charge on oxygen. -2. That's always the charge unless the vibe is off. Now we have to figure out the charge on sulfur. So we have 2 sodiums, so +2, plus sulfur. Oxygen is -2, we have 4 of them. -8 is equal to 0. So what is sulfur? Ella.
Sulfur is +10.
Is it? Everybody in agreement? -1? How'd you get -1?
No, I don't know.
Okay, don't say things you haven't even figured out.
7 minus 8. Yeah, it is negative.
Is it 4?
-1. How'd you
-1?
get 7?
6.
Is it 6?
Yeah.
Well, it's 7
Or
minus
it's
2.
7 minus 8.
6 is 8.
Where'd you get the 7?
It's 6.
Two
No, no.
That's an X.
We are.
Oh.
Six.
It's 6.
Oh,
But don't
this is sulfur. It's not a 5.
Bro, why did they have to make that?
Okay, so then it's
I know.
It's
I
negative
need
6.
to drum
It's-
my 5s.
It's -6.
No, plus 6.
Hands up for +6. Hands up for -6. Oh, we have time.
Oh, wait, you have to move it over.
You have to move it over. So +8, +8. I'm doing the full algebra.
Oh, yo.
So I-
2 plus S is equal to 8.
And then
-2 minus 2. S equals 6. You've been doing too much advanced math. You've forgotten the grade 9, 10 math. It's okay. It's okay. It'll come back. In this case, what is oxygen? Ashley. Oh, that's no. You don't have to get this far. What is oxygen always unless the vibe is off? -2. There we go. And then do the math. I'll let you write out the equation, and then I'll ask someone.
Wait, how do we know when we know which is which?
What? How do you know when what?
Which is which? I don't know if that makes sense. Like, how do we know that for this one we don't know what the end is?
Well, first I told you that's the one that I want you to figure out. And number 2, it's because oxygen's always -2 except when the vibe is off. When it's H2O2 or it's with fluorine. The two extremes. Hydrogen's on one side of the periodic table, and fluorine's on the other. We have the most, almost electropositive and extremely electronegative. What is nitrogen in this case?
No.
Not. Glad?
One.
I got one.
What? It's 5.
How do you know?
Because I know -2, and there's 3 oxygens, so that times 3 is -6. And because you have -1, it's -5.
Positive.
No, that means it's fine.
Maybe positive 5.
Yeah, positive 5.
That's what I meant to say.
Right?
I could
Oh,
say,
oh.
I just like.
You were testing everyone else.
Exactly.
Well done.
Just like that.
I do that all the time when I get things wrong. Practice another one. I hear the chorus of yeses. Please. What is the charge on that nitrogen? Also, for that particular question, there's a shortcut way. It'll probably take you half a second to do. And there's a long way in which you will calculate a lot of things. However, both will arrive at the same answer. Can anybody see the shortcut way?
In this one?
Yeah.
Add the 3 and the 2
Hmm?
something. No, never mind. Never mind.
2 round and 6 out.
Pardon?
Just do 2 round and 6 out.
Two.
And
Yeah, that's the way. I mean, if you're to do an oxidation number, how many N's do we have?
2.
2. And how many oxygens do we have?
6.
6, because if we take the 2 on the outside, we multiply. So what's calcium?
Plus 2.
Plus 2. And then we have plus whatever N is, and we have 2 of them. That's the one I asked you to find. And then we have 6 oxygens, what's the charge there?
Plus minus 12.
Minus 12. And the whole thing, it doesn't have a charge, so it all equals 0. So what is N?
5.
N is 5. Does that look familiar? What is this compound, NO3? What's its name? Nitrate. Does it look familiar? We just did it. So just because we moved it to a new, with calcium, and the oxidation number is not going to change, it's still going to be plus 5. So the quick way would be to recognize, oh, it's the same thing. And if you have a case like this and you need to know the oxidation number of that one, you don't have to keep nitrogen in there. You can just go, oh, we need the N. I'm going to do nitrate minus 1 because that's what that is. So with the calcium, we have to double. But if we just do this one, then we can go N minus 6 equals minus 1. N is equal to plus 5. So you can pull out the ions if you need to.
Where
Yep.
did the 12 minus 12 come from again?
How many oxygens do we have in here if this is nitrate?
3.
3 inside the brackets, but knowing that there's 6. And then each oxygen is
Negative 2.
Negative
Oh,
2.
Okay, okay,
2 times 6 minus 12. For each one of these, determine the oxidation number of the one asked for. So this is the compound. I want the oxidation number of sulfur in there, manganese in there, nitrogen in there, sulfur in there, carbon.
Is it just the oxidation number of the whole thing?
Pardon?
Is it the oxidation number of the whole thing?
For the whole thing?
Yeah, like what are we finding?
The one that's given afterwards. So for the first one, you're finding sulfur. For the second one, you're finding manganese. So after the comma, it tells you the one that we want.
What's the second box for?
I didn't know how to make proper tables. And so I made a big table.
It was 2 boxes.
Because I don't know how to make tables properly. Update, what are you doing? That's why that wasn't. just fell at the table and just realized, well, not realized, I thought the next section I wanted to do, given the guesswork with the algebra, maybe a little bit of practice right now would be worthwhile. So I just printed something off. And what's sulfur?
Stop.
4. Manganese, nitrogen,
4.
sulfur,
Negative 6.
-6 or 6?
I just got positive.
Positive 6. Put question mark. Carbon,
4.
4. Okay. I got a worksheet I'm going to grab. It'll give me practice at identifying reducing agent, oxidizing agent, and oxidation numbers.
A reminder that this is a finished product over here. I think I can throw it by developing. Can I see like version? This one might be.
We're almost done. No more needing to take berries. It's so long for what? Like, this is so much easier. Yeah. But I get it because they're like the same, they're super expensive. The few times I did take a few, it took like 15 minutes. So nice. Yeah, we did it twice. Oh my god, I need to sleep. I got like full like 7.5 hours of sleep. Like I should be. Yeah, me too. On the days that I got more sleep, I'm more tired. I agree. The days that I got up at like 6 a.m. is the days that I have a good day.
One day she just gets
Doesn't make sense. Time does this? You're joking. What? This class ends at 9:30 and it's only 8.
Okay, that's why
And then
I
at
hacked that I
9:45.
learned. I hacked that I learned. As soon as you hit the mark that it's like half an hour left, it's like a break. And your brain like thinks
Really?
that yeah, I don't know. My brain thinks weird things. I'm gonna go to the bathroom and close my mouth.
I'm gonna drink.
Yeah, come with me.
Okay. Your worksheet. You can't game. No game. Just. I think you're lying, but I don't believe Katie gave up. Was that you?
Sorry?
That was you. On there.
Yeah, I was just open face on
Yeah?
him.
You right there?
Yeah.
Who's there?
Thank you.
You're welcome. I will give you a multiple choice sheet to go with it. But I wanted you to be able to get started. Is anybody confused about how they do the answers for 1 through 9?
Which one do we assign oxidation numbers? Chlorine.
It's all chlorine. And then the answer on the right, you just will fill in either A, B, C, D, or E, or A, B, A, C, A, D, A, E, or B, C. And use the same answer key for both. I will quickly print off a answer sheet. Calendar, no. Zip. Why don't we say 15 minutes to finish it, and then I'll mark it?
Like we're handing it in?
Yeah,
We're handing this in?
yeah. And if you do well, I'll count it.
You're handing what in?
The worksheet I just gave you.
Oh. Which one are we finding for each one?
What does it say in the very top?
Oh, come on.
And it's a total of
First one.
26 questions.
The first one. This one. How do you do HCl? I got some shit out.
Minus 1. Because like plus 1 equals
I know, but then look at number 3. Oh, it's minus 1. Well, look at 3 and 4. I got the same answer for both. Three is plus 1. 3 is plus 1, but 4 is also plus 1.
No, it's minus 1.
4 is minus 1?
Yeah, because what equals minus 1? Like CL, we have a
Oh,
set.
but I thought you said you can only have. Can you only have like, Mr. Dufa?
Yep.
Does each answer have to be different?
No?
Yeah.
I mean, they could all turn out to be -2, and then your answer be A.
Oh, okay.
Oh, so there can be multiple.
Oh, it's not matching where, oh yeah, classic. It's not matching. I just gave you a string of numbers because if you notice, it goes from -2 to +7. Those are all the oxidation numbers that you're gonna find. There may be some in there that are never used. There's some in there that you might use more than once. I picked the range so that you had the complete range to pick from.
Do you get plus 5
The
for 5?
second one's 0. Plus 5, so it's 1.
I don't have my keys.
6. Yeah.
Second one is not 2. It's negative
Because it's CO2. You don't have like O2.
Yeah.
It's because we're 2CL equals 0, which means that CL equals 0.
I will go get the multiple choice
Oh,
sheet.
wait, sorry, you're right. I thought it was minus 2.
first document.
For the third one? Oh, yo, it's gone. Yo, it's gone. I got AB for the 7.
What?
Yeah, I got AB for 7.
I got E for 8. Is that what you got?
I got AC for 8.
For 8?
Yeah.
Oh, yeah, you're right. And then BC for the last one.
Yeah, I got AC for those.
What'd you get for 8?
AC.
Plus 4. B.
What's with these fucking EEs in it?
There you go. Yeah, I got it.
Okay, Etienne's not here. Lavina?
Yeah. Yeah.
Theo's not here. Josh isn't here. Worksheet? I think you have about 11 minutes left. And then we're kicking it in. If you do well, we will count it.
It's a quiz.
Worksheet.
What is this?
Wait, that's your answer sheet.
Oh, you scared me with this. Can I have my worksheet though?
Pardon?
Can I have my?
Is chlorine always negative 20?
What?
Is chlorine always negative 20?
What is chlorine always?
Negative 2. Or 1. Wait.
There. But is it always?
No.
Because in the section, you're going to find out a lot of times it's not. Andrew? So for each one, just bubble in as needed the answer from the answers on the right. And for those who just walked in, it is not a matching where there's one of every type of charge. It's
How do
just
you do
a
it?
selection.
How do you do like A, B, A, C, D, E on this?
Do you just circle in both?
Yeah, you just circle in both.
Oh, that's pretty genius.
Yeah, I thought so.
Fake news.
When I figured that out, I thought like, I am so smart.
So it's like A, N,
S M R T.
Oh.
pretty genius.
Yo. Can you switch real quick? I just gotta write it down in the index. I just gotta write the answers.
Ashley?
So B,
Me.
double D,
Matt.
C,
Again.
For number 3.
Wait, news.
Yeah?
K is plus 1, correct?
Pardon?
K is 1.
Usually. Yeah. Well, it's, what is it? Okay.
Well, it's on the chart, it's 1.
Yeah, it's not very metal.
Yeah. So it's in order, so plus 1, plus 2, plus 3, plus 4.
Yeah.
Okay.
No. Plus 1, plus 2,
Yeah.
plus 3.
Yeah.
Plus or minus 4, minus 3, minus 2, minus 1. So we get minus
Oh,
2
okay.
fractions.
No, I have it.
Yeah.
Sorry.
Which is always true except when the vibe is off.
A. Wait, did you do A, B? I did A, B, A, C.
I did AC.
6 and watch it.
just say AC/DC?
Really? What were they? Yep. 16 seats. I put my things in. I did AD, AD, AD. I didn't put EC. Yeah. So nice.
They're very loud.
Is there one that you wanna understand? Yeah, I'll just do that. Do 15. Find 15. We don't know what happened, but what does L have? Yeah. Negative 13. What does minus 14, what does it equal to? Yeah, because the charge is, it just equals the charge. And there's,
Let me see your sheet.
and then minus 14 equals 0. Or and then 2 minus 14
Is there anybody on the backside yet?
There's
Yeah.
The backside?
Yeah.
Oh my god.
I'll show you how to do the backside with this example before you start once everybody gets to there. But if you're once you get really good at oxidation numbers, then it's a lot easier.
Like, you could just do this and CL is good. Like CL2 is 0, or CL1 is what? CL, just regular CL, it's negative 1. But there's two of them, so it's negative 2, which means that and then has to be positive 2 because the charge is 0. So that's how you do it quick.
And
For
like this one's
oxygen.
equal to negative 10.
Yeah, but because, yeah, do that.
So we don't know what
Wait, I think we did this yesterday. Nuke, did we do these yesterday?
Oxidation numbers?
No, the little second page.
Yeah, reducing the oxidizing agent. Is enough people close to that? I could ask you to stop. This example, I won't say it's easy, but it has an easy trick in it. Can anybody see right away which one's being oxidized and which one's being reduced?
SO3 is being oxidized.
This is being oxidized because the number of oxygens are increasing. This is being reduced because the number of oxygens is decreasing. So that's the classical definition, and this is a classical case. However, if we wanted to figure out from first principles, the way you're doing it in your sheet would be, what is the oxidation number of AS in here?
-3. Oh, wait. +3. 1.
Now I feel like you're just throwing numbers out. What is oxygen? Then yes, +6, -6.
No, 9-6.
Because oxygen's -2, with that 3, -6, so it's -6. That -6 equals -3. So what must AS be here?
3.
Yeah,
I said that.
yeah, but you were guessing.
No, I actually meant that.
Oh, okay. I thought you were guessing. So I'll give you a second chance. What is AS over here?
Always negative 2.
3.
Negative 2, 2 is
0.
So, and then
This time I'm guessing.
equals negative 2.
What's-
Oh, wait, no, it's 5.
O will always be
Why?
negative unless it is
Because there's
one.
2 more negative 2s from oxygen.
Yeah, there's two more negative twos. So this is minus 2. This whole thing's minus 8. The whole thing has to equal minus 3, so it's plus 5. Sorry, plus 3 over here. So this one from there to there. So this one lost or gained electrons? Gained. It became more negative. Lost. So loss of electrons, oxidation. IO3. What is the charge on the iodine? I'm going to get rid of the oxygen and just go iodine. What's the charge?
5.
Plus 5? Yeah, because there's 6 minus 6 from the oxygen. The whole thing has to equal minus 1, so it's plus 5. What's the charge of iodine over here?
0. Oh,
Negative 1. So gain or lose electrons? Did it become more positive or more negative?
Gain. It's a gain.
Gain. And gain of electrons is a reduction. How many electrons did it gain, by the way? If it went to minus 1 from
6.
plus 5?
6.
6. Plus 6 electrons. So now that we know that this one was the oxidation and this one was the reduction. So which one is the reducing agent?
The one that the ASO3.
ASO3. So this is the reducing agent because it helped the other one get reduced. This one is the oxidizing agent because it helps the other one get oxidized. So the one that is reduced is the one that is the oxidizing agent. The one that is oxidized is the reducing agent. The reducing agent has its charge go up. If you just want a very quick way to do it, the oxidizing agent has its charge go down. So the one that's reduced has its charge go down, the oxidizing agent has its charge go down. So on the second page, I just give you a reaction and you have to figure out, okay, check all the charges, which ones are changing their charges, then which one goes up in charge, which one goes down in charge, and pick out the right ones. Now, I'll give you a really, really big hint. Can your products ever be a reducing agent or an oxidizing agent? No. So you'll notice I gave you the choice of the products on there, and you could pick them if you wanted, but that's mostly to see if someone thinks that.
So if there's no O in it, then what ion do you look at if it's reducing it?
You were just looking if it changes charge. So this question would be unchanged. You could change that oxygen to sulfur in both cases. Sulfur's in the same column, it's minus 2. You'd go, oh, it must be minus 2, and you're going to figure out the other ones.
What if it's H?
H?
Yeah.
Oh, now you've effed my example. ASH3, it's a completely different case now, with charges. But we can still do it. H3 minus, this is minus 3, goes to ASH4 minus 3. This is going to be weird, plus I minus. So you want this example. Right, what's the charge of hydrogen?
+1, +3.
Not in this case. Because hydrogen with a non-metal, that H is +1. But if it's with a metal,
-1.
it's -1. AS is a metal. And the hydrogen will be written second. So this hydrogen, these 3 hydrogens are -3 overall. So what would the charge be on that astatine? Or hold on, what is AS? Astatine or arsenic? Oh, we're arsenic. Arsenic and old lace.
Is it 2?
Yeah, +2. So we're getting different things because we now have different compounds. However, what is it here? So what's arsenic in this? if we have H4 to -3?
Plus 1.
+1. So in this case, it went from +2. So what, the hydrogen never changed. We could see what it is. We know the rules. It's always going to be -1. So we go through and we see what changed. And what changed was the arsenic. It went from +2 to +1. So it went down in charge. And if it goes down in charge, +2, then this is the reduction.
The oxidizing agent.
And so that'd be the oxidate. But what I don't know is, because I just substituted, if they both go down in charge, this reaction is impossible. So we're going to find out. What is the charge on iodine here?
Is H plus or minus?
Since it's second, it would have to be minus. And this is one of those you go with the vibes. It's not a metal, but we put it second. This thing that's second is always negative. So -1, we've got 3 of them. The whole thing's -3. Sorry, that's -3. This has to be -1. So iodine here has to be
2.
+2. And we know that iodine here is -1. So it went from +2 to -1. It decreased in charge, which means this is also the reduction. So this is an impossible reaction. This wouldn't happen. These two wouldn't react. And it's because I just substituted hydrogen in there. They probably bond in a different way. However, the overall principle that you just look at the charges and see what's changing is true.
For the second example on the sheet, though, there's like more than one like ion.
Yep.
How do you know which one to look at, like if in a compound?
Just check the charges of all of them. Ones that don't change don't matter. So you're talking about the very first one. There's like the first one,
No, the second.
the second one.
Number 8, third.
Yeah. So the second one gives you 3 products, but with say H2O, does the hydrogen or oxygen change their charge? Actually, it might, because it looks like the hydrogen might. Oh no, it doesn't, because that's ammonia. Oh, that's a good point too, because we write ammonia weird. I'm sorry, but this is one of the ways that it breaks the vibe. What's the charge of hydrogen in here? +1. There's 3 of them, so it's +3. What's the charge on nitrogen if it was to have a charge?
Wait, I thought it was
Minus
minus
3.
1 being second.
Except we just never write ammonia that way. We should. We should write it like this. And we should put the most electronegative one second. We just, out of tradition, never do. But if you look at the vibe, nitrogen should be -3. Like it always is. It's in the right column. Hydrogen's in the right column. Like everything else lines up. It's just a traditional case. The student was a month and a half ago, sent me a meme and was like, chemistry's easy. You just have to memorize all the rules and then be able to do all the math and then memorize the 3,942 exceptions. But at least it's not biology. Because in biology, every rule is an exception. But it's not too bad. Nitrogen should be -3. Hydrogen should be +1. It is with a non-metal. It follows the rule in every circumstance, except we write that one in the wrong way. And so that's what I mean by the vibe. And I hate that answer probably as much as you do. All the teachers were given an opportunity, mine was a few years ago, to do pottery. And you have to how many of you have done pottery? How long do you have to I don't know, knead the clay?
10 seconds.
Well, I was told until it feels right. What kind of stupid instruction is that? I want like 1 minute and 32 seconds, or 15 seconds for every gram, and you weigh it and you get a precise amount. Feels right. But it's true here as well. Done?
On this page, yeah.
As soon as you're done, I'll take it in. Yep. Because I think nailing down oxidizing agent and reducing agent will really help with the next section. And it's the last day. First class. And you want to be in a dark classroom. I thought a little bit of practice might be more helpful than just going on to the next section. In the most unhelpful way possible without providing the answer, yes.
So, I looked at CU,
Mm-hmm. Yep. There's only one thing that changes. No, there's two things that change. No, oxygen changes. Because what's oxygen here? -2. Oxygen there's -2. But you have actually written one that has changes. Like it's on your sheet, and I don't think I'm sheet might point it out. What is nitrogen here? What's it there? So nitrogen changed. So you've got, when I do these, I draw arrows. So like that changed. It went from +2 to 0, and this one from -3 to 0. And so one gained electrons, one lost electrons.
Okay.
What did this do?
Wait, dude, I'm so confused on this.
Mm-hmm.
So, I'm trying to figure out what gets, so, the reducing agent gets oxidized,
Mhm.
correct? So I need to figure which one has more oxygen.
Mm-hmm.
So, let's see.
You can a product be an oxidation number or reducing agent?
So,
Can a product be an oxidizing agent or reducing
oh no, it
agent?
can't, it has to be.
So you're picking one of these.
Oh.
So this one's oxidized.
Yeah.
So it's the reducing agent. And that's because, and I would start writing on your sheet, like write the charge, like that is +5. And this one, hold it, this wasn't +5. This was +3. Now it's +5. And I usually, when I'm doing it, I'll draw an arrow. Because then I went +3 to +5. That had to lose some electrons. And then this, that iodine, here, when you work that out, this is +5 to -1. So that had to gain electrons. So this one was reduced. This one was oxidized, which means this one's the reducing agent and that one's the oxidizing agent. Does that help?
But can you repeat that?
Sure. This is +3, that's +5, right? On the other side. So when I do, like if I was working on the sheet, like even now, I would draw an arrow. Just so I know where it's going, and then in my head, I go, okay, +3 to +5, it lost -2 electrons. And then I know, this is the oxidation because we've lost electrons. That makes that the reducing agent.
Okay.
This one went from +5, and I draw an arrow to -1. That is adding electrons. It went from positive to negative, so I had to add 6 electrons. That means it's being reduced, which means it's the oxidizing agent. I think that's your very first question, too.
Yeah.
Yeah, it is.
Yeah. I will say that one of the questions, is weird.
The lost one.
What about when like the like say there was like a plus AS? Like do you just add it? Do you add that charge to that?
Say your example.
Like if you had AS 03 minus plus AS
AS 3 minus plus.
AS plus IO 3 minus.
What is it going to? Like, what is this? Why plus IO3 minus?
Because like there's like 3. Like if there's like 3 in like the
Oh yeah.
You can
Yeah, okay, that's fine. Now but what's on the other side? One of these is not going to change. So if you have 3 things, like if I have, for example, copper plus aluminum plus 3 plus hydrogen iodide, just do that, and you go to CuI2 plus Al plus H plus. There's lots of things here, but what the really important thing is that and I know because I've set it up that way, this copper is plus 2, right? This iodine's -1, that iodine's -1, so it doesn't matter because it didn't change. This hydrogen's +1, that hydrogen's +1, it doesn't matter because it doesn't change.
so we only care about the ones.
We only care about the ones that are changing. This copper went from 0 to +2, so at -2 electrons. Loss of electrons, oxidation, that's the reducing agent. Aluminum went from +3 to 0. +3 to 0, that's +3 electrons. Gain of electrons, that's a reduction, so that is the oxidizing agent.
Okay. So you just cancel out the ones.
Yeah.
Okay.
The really interesting ones are the ones that do what kind of
What about if there's like no place to cancel them out on the other side?
Can we just look at this?
sorry, what?
What if there's no place to like cancel them out on the other side?
What do you mean no place to cancel them out?
Like if you have like your PB goes to like one area.
Mm-hmm.
Oh, so like one of them would cancel out and you just have one.
What's the charge on PB there?
Um,
Like, how do you know that that's oxidized and that one's reduced?
Oh, I was
Come on.
because like it goes to O2.
Well, here.
But like yeah, I get what you're doing.
I'll give you a very similar example because that's the tricky one. It's not tricky. It does something clever. Let's go with,
Yeah, for a second.
but I'll take away all the other things. So I've got copper plus 2. Plus copper solid goes to copper plus 1. What did this do? To go from +2 to +1, what do you have to do?
It gained an electron.
It gained an electron. Gain an electron reduction, oxidizing agent. What did this one do?
It lost an electron.
Lost an electron.
Okay, so you could just put them both.
So
in the same
you can have them both go to the same product,
Okay.
and you still have an
I thought they,
oxidation and
both used
reducing
their own,
agent.
like, product.
Yeah, and the secret is the other problem, and I don't know if there is an example of this one or not, but I know it comes up somewhere. You know how there's 2 went to 1? You can have 1 going to 2, and it's its own agent for both. So work out the charges, and if there's only 1 charge on one side, but it goes to 2 things, well then it's both. And if there's 2 things going to 1, well that's fine because they both lost and gained electrons. So those are the only tricks that can come up. just saw another, I think it was the worst AP question I've ever seen in my life. It sets it up and it just talks about redox the whole time. And then it says, look at this reaction, balance it, and do all this stuff. And when you look at the reaction, it's an acid-base reaction. None of what they told you was relevant to it at all. It's a side reaction to what they were talking about.
What if in one case,
Literally.
what if in one case it reduces and in another case it increases?
Show me.
The charge. And this CL goes to plus value, which goes to minus one.
Right.
So it's
So what is, I just want to see if you're ready. Why do you have O0 there?
this option is charge zero. Yeah, because
What's the charge on hydrogen?
minus one. But it's separate.
With
It's
the non, with the non-metal though, it's
oh,
plus 1, and then oxygen is minus 2, so it makes total sense that hydroxide is minus 1 overall.
so
So-
it's minus two.
Yeah. So
So
that
it
is,
doesn't change.
it doesn't change.
But for CL, but like CL is
Yeah.
goes to 5 and
Yeah.
goes to that. So
Yeah.
which one do you choose?
Well, you don't have to choose.
Oh, because it's just CO2. Well, yeah, you do.
You do.
How do you do these
But now you know if it's reducing or increasing
Did you get
the
it?
charge.
Yes.
Wait, so
I'm
if
helping
it's
you in the most
electron
annoying way possible because I want, you know this, you can get it. There's a little leak.
oxidation.
If it gains, it's a reduction.
If it gains, it reduces.
It's like a reverse.
Is it
How,
like whenever
like-
it's just bigger? It's going up by 5, so it's going to be reducing agent.
It's going to be the reducing agent, yes.
And
And
if it loses
what is
it,
the
it's
oxidizing agent?
Oxidizing
Did it change?
oh, they're both. Oh,
Wait, what?
Well done.
Like, so both is the oxidizer and the reducing?
No, I'm not going to say anything. Ready to hand it in?
Can we not hand it in?
No, hand it in. Oh, where'd my phone go? You must hand it in before you go. And I will mark it as you hand it in.
Wait, so oxidizing and reducing agents can only be reactants, right?
Sorry?
The oxidizing agent and the reducing agent can only be reactants.
Yes.
Okay. So why do you have answers for their products then?
To see who's confused. Literally just to see who would be willing to put that down. Good?
See how badly I did.
There you go.
Wait, you just took a photo of that? Oh.
Okay.
Does that count?
Yep. Can do. Waiting for a photo. Well, I need a flat surface apparently, and I need more light. Sorry. I will upload it to ZipGrade right after class so you can see how you did.
Hey, you guys should go.
You're welcome. Thank you.
You're
And you
good.
can keep it, and then you can correct it. It doesn't count if it will harm your mark. So in that case, it's just practice. And for the first day, pretty good. Like,
Oh, I guess we should be back.
oh, put this in.
Oh, this should be fun.
As soon as I mark yours, easier to set, right? I will turn the light up because my
Very badly here.
camera's having problems taking pictures under too low light. Did I do yours?
No.
It'll be up in a minute, so you can go through and correct it. It doesn't count if it's gonna drop your mark.
Okay.
It only counts if you did well. So you can go through, correct it, and then figure out.
Okay.
Do you want just a zip feed or this one?
I'm just gonna like take a picture of it right now. Like you did in pen. I'm gonna upload it so you can see what you did wrong.
Did you get your own?
Okay, this will automatically overwrite the old one.
Bro, I swear it's definitely not AC that I changed because it's supposed to be CA. Wait, Noof.
Yes?
Didn't take, wait. I wanna try this though. This is the one I thought.
You're like, I swear it's wrong. I'm going to change it. Well, I haven't shown you the answers yet, so
I
okay.
definitely got this whole thing.
Hey, well, that's probably
But you only get to do this once. Now, you have to take the grade.
I mean,
Wait,
that grade
are
is,
you going to
look at that
soccer
grade
or
still
no?
works. It's
I don't
not
know.
gonna- You're not gonna use it.
Okay, as long as I can't move my grade up, I'm like fine. My
Oh,
grades
frick.
already.
Wait, how's it 28? It says I got 3 wrong now.
Yeah.
And I had 2 wrong, and I just switched them around. So there's 2 ends.
I will put it on.
Yes, I need
Great.
I will upload it. It won't count if it makes your mark worse. But that way you can see your answers and you can correct it.
What if they both made your mark worse?
Can we like redo it?
Well, you're gonna get a quiz on it for it.
Like later? Is this gonna be on acids and bases?
No, this is not us. Like that. That would be cool. Or help you study for the final. Maybe we should put it on.
No. This is supposed to be a break.
I'm not very
Maybe. Do you know that you used to do grad during this weekend?
Used to do what?
Grad. You'd go to Vancouver, and we would have grad in like the convention center.
Oh my god.
And then you would come back to school.
That's crazy.
schools do grad.
Yeah,
Before you actually.
before you grad.
Yeah. I wouldn't want to come back to school.
Same.
Nobody did, because they come back and they're like, forget it, F it, we're done. Like,
Yeah.
and it's like, you have final exams, and they're like,
What?
I can't do anything.
Yeah.
Having grad at the end is so much nicer. And you can genuinely relax. And we can all genuinely applaud and go, yay!
Wait, can I do this?
Yes.
Oh, Kristen, how many marks is the test? Like, how many like multiple choice?
It's good, it's similar to all the other ones, because it's the same block size. So it's not a bigger test, it just covers that material. So there'll be questions I don't ask, because I can only fit so many questions in. Yeah. Wait, what?
I'm gonna head out. Bye guys. Bye, Mr.
Can I use that?
Yeah, I'll use it if it works. And if you go through, once I release the answers, you're like, no, Mr. Neufeld, you're wrong, because I quickly whipped in the answers. So I have to double check it.
Thank you.
And now I panic Cor Lavina.
I'm just gonna say.
But you're working hard. And if you want to stay here all assembly, I would sacrifice myself and stay here while you did it. I mean, I'd really hate to miss assembly, but if you wanted to.
I'll just guess for that.
No, don't guess. Work on it. Slow it. Take your time. We have a lot of time till the next class.
Can I get permission to skip assembly for emotional support?
Emotional support. I think that's
I think it's
necessary.
like crucial.
I think it's crucial as well. There.
Enough class, enough calc is like right beside us. Okay. So if it goes from -3 to 1, it's losing the electrons, so it's an oxidizing agent. So it's an oxidization reagent? Yeah. Yeah, the oxidation
so silly. They just changed the freaking name. Oh my god, Mutual 10 minutes also gone. Guys, it's not just you. I really want my iPad. It's not even funny. Oxidization 25 For H2SO4, did you just make S negative 2? I didn't know how to do it. Because I didn't know how to make S. Just make it. So don't guess.
Don't we have a vacuum generator that works off of water? You put scooping on it?
Casper?
I have sadly had 2 students with Parkinson's. It's terrible. Do you have advisors? I should email that notice if you were gone, just to say you were working on chemistry.
Sure. Let's check. Mine's Mr. Pasquale.
Mr. Pasquale, as in
Vittorio.
Vittorio.
Mm-hmm.
How do you pronounce his first name?